In this video, I want to have a look at logarithms. So before we actually get into logs and what they are, I want you to have a look at this equation here. So we have 2 to the power of 5 is equal to 32. So what that means is that every time we're going to be multiplying by 2, and we're going to do it 5 times. So we're going to have 2 times 2 times 2 times 2 times 2 gives us an answer of 32. So what's happening in this equation is this number here, this 2, is the rate at which something is increasing each time. The 5 is telling us how many times, oops, press the wrong button again, tells us how many times it's increasing, and this gives us our final size of our answer. So the 2 means that it's doubling every time. The 5 means that we're going to double it 5 times, and we get a final answer of 32. So writing an equation in this form is really handy when we know a rate of change and we know how many times it's going to change or how many time periods there are, and we're trying to find out the final size or final answer. But sometimes we'll be given a problem or a situation where we know what the final size is, or we know what we want it to be, we know what the rate is, and we need to try and figure out how long it's going to take to get up to that number. So when we need to do that, we want to sort of rearrange this equation to make the time the subject of the equation instead of being in the power. So to do that, we're going to use something called logs. So to rewrite it, we'll have log base 2, so the base of this expression, this exponential index expression, is the base of our log as well. Then we're going to have our 32 here, and that's going to give us an answer of 5. So the base stays the same, so the base is here, so it's the base of our log. Then we have the final size of 32, and then we have our number of time periods over here as the 5. So when we read a log, we're saying 2 to the power of something is equal to 32. So 2 to the power of something is equal to this number 32, and that something is 5. So 2 to the power of 5 is equal to 32. So to write that more generally, we're going to write x equals a to the y. So this is index notation. If we want to then rewrite that in log notation, we would write log the base a of x is equal to y. So we're saying a to the power of what is equal to x, and it's a to the power of y. So these two equations mean exactly the same thing, it's just different ways of writing it. So let's have a look at some examples. So our first one, we've got written 4 to the power of 5 equals 1024. So that's written in index notation. If we want to write it in log notation, we would write log. Now this base is the base here. Our final answer is what comes next, so 1024, and that's going to be equal to 5 because 5 is the power up here. In our second example, we're going to go the other way. So this one we have it already written in log form. So we've got log to the base 5 of 625 is equal to 4. So rewriting that in index notation, we would have a base of 5 to the power of 4 is equal to 625. Our next one is asking us to solve an equation. So we have x equals log to the base 2 of 8. So to help us solve this, it might be a good idea to rewrite it into index notation. So we're going to have 2 to the power of something, so x, will give us an answer of 8. Now we should be familiar with our powers of 2, so we should be able to say that x equals 3 because 2 to the power of 3 is equal to 8. It's important to know as well that all these rules work when we have fractional or negative powers as well. So for example, if we were solving this one, we've got x equals log to the base 5 of 1 over 25. So if we write that, we would have 5 to the power of x equals 1 over 25. And again, looking at your index laws, we should be able to say that x is equal to minus 2. And that's because 5 to the power of minus 2 would be 1 over 5 squared, which is equal to 1 over 25. So our x is equal to minus 2. So the last little bit I want to look at in this video is how we can use our calculators to solve problems involving logs. Now your calculator can only solve certain logs. So we can solve problems that involve log to the base 10 or problems that involve log to the base e. Now this one we're not going to look at in this topic, we'll look at it later on. So in this video we're just going to have a look at log to the base 10. So on your calculator, it's just the button that says log. So it's this one here. And above it, it's got that 10 to the power of something button because those two things are related. So for example, if we had a problem like 10 to the power of x is equal to 800. If we wanted to solve that, we'd first rewrite it into log form. So we'd have log to base 10 of 800 is equal to x. And then to figure out what x is, we would put this in our calculator. So we're going to write log, and because it doesn't put the base 10 in there, but that log button only does base 10. So we've got log of 800 would give us some huge number, but it's roughly equal to, so approximately equal to 2.9. So that's an introduction to logs.